Concept getters, I hope everything is going well. I hope you're good. I hope you're healthy. I hope you're alive and kicking and that you are ready for the exams, right? Guys, today I'm going to introduce the reduction formula. So this video is going to give you everything you need to know about reduction formula in trigonometry. And this is how you simplify without the use of a calculator. So if you don't have a calculator or the examiner says don't use a calculator, guys, this video is exactly about that life. All right, so I'm going to start by introducing the concept. I have this mnemonic that I call the ooh. You know, some of my former students or those I've taught before live, they know the mnemonic. So I was like, you know what, let me share this with my concept getters. So let's go in here and let's do it together. All right, so I'm gonna go in here and say mnemonic of MrSir. This is mine. All right, so how this goes is I'm going to first explain how the works. No, so if you have, let's say, remember with the mnemonic you have to use the Cartesian plane, right? When you have a Cartesian plane, we know that it will always have a 0 degree here, right? It starts there. So the first thing that you should know about the mnemonic is the rotation. So I'm going to say number 1. You must know how the rotations work. The rotations for reduction formula. So just know that when you have a 0 here, when you move in the anti-clockwise direction, you move in a positive direction. Okay, and when you move in the anti-clockwise direction, this direction, you're moving in the negative direction. So basically, if you move from here and you land in the first quadrant, let's say there's a line and there's this angle here, you're moving theta. When you fall into the quadrant, you're moving theta because theta is greater than 0 degree but less than 90 degree. What are we saying this is? This is what we call an acute angle, right? So just know that every time when you move an acute angle, an angle greater than 0 degree but less than 90 degrees, you are moving theta, right? And then it's always going to drop into a quadrant. That's basically your second right? So if you're moving in the anti-clockwise, it's going to be a positive theta. But if you're moving in the clockwise, in this direction, let's say you're moving from the 0 and then you drop into here, into the fourth quadrant. So just know that you moved theta, but in the negative direction. Therefore, it's going to be negative theta. Does it make sense? So every time when you're moving from these lines, just know when you're moving from this line here, or you're moving from this line, or from this line, or from this line, into the quadrant, or you're moving from this line and then you're moving into the quadrant, you're moving theta. If you're moving from this line and you're moving into the quadrant, you're moving theta. Do that make sense? And then whether the theta will be positive or negative, it will be determined by the direction. If you're moving in an anti-clockwise, then the direction will mean that you are moving a positive theta. When you're moving in the clockwise, then you know that you're moving negative theta. Does it make sense? So now those are the rotations, right? Now just know that every time when you're moving in this direction, it's positive. And when you're moving in this direction, it's negative all the time. So now let's get our multiples of 90, the long ooh, right? So let's go there. So let's say you're moving from here, right? When you're moving from one line, not dropping into the quadrant, but instead you're moving from this line, the x-axis, onto another axis here. You see here, you're moving a full-blown 90 degree. So basically, even here it's 90, here it's 90, here it's 90. Do that make sense? So just know when you're moving from one line to the next line, you're moving 90. But when you are moving from one line and you skip one line and you go to the next line, let's say you're moving to this one, just know it's 90 plus 90. So as you can see on my long here, I said on top of it, I wrote times 90, meaning those are multiples of 90. And then on the it's an acute angle, meaning you're always dropping into the quadrant. So the long is for multiples of 90 going to the lines, right? And then the is when you are dropping, or you are dropping, or you are dropping. Makes sense? Or you are moving from here, you are dropping. So now that you understand the direction, the rotation, let's find what's really going on here. So let's find the angles now, the multiples of 90, all the multiples of 90. So let's go anti-clockwise first and find the positive angles. Then we're going to go clockwise to get the negative angles. So when you start, always we start here, right? So we said we're starting at 0, and you're going to say, ooh, makes sense, which is going to be your positive 90. So which means here we have positive 90 degree. When you move from here again, you say, ooh, makes sense. So it's 290s, and in total it's going to be 180 degrees, right? You're moving from 0 again, you say, ooh, then here it's going to be your 270. So you have, here you have 270 degrees, right? And then you say, ooh, full rotation, which is basically 360. So here you have 360. Remember, you're starting here at 0, right? Let's move clockwise now. Clockwise is a negative rotation, right? When you move from here and you're saying, ooh, you stop here, you moved 90, but because it's in the negative direction, it's going to be negative 90. Does it make sense? So I'll just say, ooh, negative 90. So here I will have negative 90 here. And if I say, ooh, you see now it's 180. So I'll have negative 180. It's a 180, but in a negative direction, right? And I move again from that 0 and I say, ooh, you see now it's a 270, but in a negative direction. Therefore, it's going to be my negative 270, right? So I'm going to say negative 270 degrees, right? And then again, I'm going to say, ooh, full rotation of 360, but in a negative direction is going to be negative 360. So here I'm going to say negative 360. So that's how you get your angles. Remember how I got my negative theta? I moved from 0 and I say, ooh, acute. Therefore, it's a negative theta. But if I move from here and I say, ooh, positive theta. So now let me give you an example, okay? If I have 180 degrees minus theta and I want to rotate this, I'm going to say, always start with the multiples of 90. Always start with the big O before you rotate the acute all the time. Even if they gave it to you like theta minus 180 degrees like this, you're going to start rotating the 180 first, which is negative in the negative direction. Because when you look at it, you can see that this is a negative 180, meaning it's a 180 degree in a negative direction. Makes sense? You start with the multiples of 90 first, the big O. Then you're going to rotate your theta later, which is your acute angle, which is your ooh. So it's ooh, ooh. Makes sense? The ooh, you drop into a quadrant. So let's rotate the first one. Let's start with this one first, right? When you have this one, you're going to say 180, which is positive because it's not written next to it. So if it's positive, I'm going to move in a positive direction. So which means I'm going to go in this direction. So I'm going to say ooh, positive 180, right? And then the negative theta means this is a negative direction, right? So I start where I stopped. Remember, I stopped here. So when I stop here, this is going to be negative. This is continuation of positive. So which means I'm going to go this direction, but I'm going to drop into the first quadrant that comes after where I stopped. So I'm going to say now, when I'm here, I'm going to say negative is this direction, and I'm going to drop into the next quadrant. So then the second O always drops into the first quadrant you come across. You don't go and pass another line or another multiple of 90. So if I stopped here with my 180 or with my 90 or whatever, and I'm going in this direction, my drop will be in here if I'm moving theta. So always, like your second O is always in your next quadrant, like the first quadrant that you come across, you drop in there. Makes sense? So now let's try this now. Boom. This one, right? Let's try this one. If I have this and I'm trying to do this one, remember, even if they wrote theta first, I'm going to start with the negative 180. Always start with the big O, right? So I'm going to be like negative 180. When I'm here, remember, you always start here, right? On 0 degree here. And you're going to be like, it's a negative, therefore it's this direction, right? And if I'm starting here and I'm moving in a negative direction, 180 degrees is going to be, you stop here, which is negative 180. And you check again now. My theta is positive, which means I have to go back now. I can't continue because continuation means negative. So I have to go back and say negative, positive direction now, which is, and you drop into the first quadrant, which means theta minus 180 is in the third quadrant. 180 minus theta is what? Is in the second quadrant as we got previously. So you can rewind the video and check. So that's how the rotation works. You'll see when we apply it in the questions. So that's the first rule of the mnemonic, right? When it comes to reduction formula, you have to understand the how they move, right? I love this concept, guys. So what is the second thing now, Mr. Sir? The second thing now is when you see tan in the question. Imagine if they gave you tan 180 degrees minus theta. When you want to reduce this, you're going to say 180, you stop here. Negative, you come back. You drop in here. Remember, all students take control, right? So in the second quadrant, we know that sign is the one that is positive. If sign is positive, it means our tan is negative. So you'll be left with negative 10. 10 what? Theta. Makes sense. And once you get that, every time when you are given 10, you should always change it to sine theta over cos theta. So that's basically our second rule. Our second rule states that every time when you see 10, change it to sine over cos after you do its the reduction. Once you do the then you change it to sine over cos. But remember, this sign here, the negative next to the 10, does not go to both sine and cos. It's going to be on the side, and you only change the 10. Clear? So now that you know, the second rule says when you see tan theta, once you are done with the reduction formula of tan, change it to sine theta over cos theta so that you can simplify further. That's the second rule. Guys, I love the third rule, right? The third rule says every time when you see co-ratios are which ones? So let me write it. The third rule is the co-ratios. Co-ratios. If you see a 90 degree plus or minus, or you see 270 degree plus or minus, every time when you see these two, as long as they are carried by sine or cos, sine will change to cos or cos will change to sine. For an example, if I have sine 90 degrees minus theta, I'll first do the right? Remember, you do the rotation first. So you're going to say 90 minus theta. When I do the rotation, I'll be like 90 is positive. Stop. Theta is negative, so I come back. I drop in here. In here, it's all of them, which means my sign is positive. So my answer has to be positive. But because I see 90 degrees, sign will change to cos. So my answer won't have sine theta, but it will have what? Cos theta. If here it was 270, same thing. You rotate 270, and then you come back because of negative theta. You drop in here. In here, it's all students take. In here, tan is positive, which means our sign is negative. So my answer should be negative. Then, only after you get the sign next to your trig ratio, or your trig ratio, then you can be like, but I see 270 or 90. So I'll be like, my 270 tells me that my sign will be cos theta. So, and again, in order to know whether you're checking which one falls into what quadrant, you check the one that they give you in the question. Is it positive or negative in that quadrant? If it's negative, you write negative. Then you can change it to the co-ratio. Okay, that's the second rule. The third rule. Now, the fourth rule, guys. I love the fourth rule. The fourth rule tells me that every time when there is no variable, it leads us to the special angles. Guys, let me erase here so that you understand what I'm talking about. So let's see. Every time when there is no variable, let's say for an example, most of the time you will see sine theta minus 180, right? This is where theta is our variable. Sometimes it's sine x plus 270, right? Our x is our variable. But for this rule, we are talking where you don't see x, theta, a, and whatsoever. We only see numbers. Like for an example, if you have sine 150 degrees, for an example, right? Every time when you see just a number with no variable, just know that you change this number, you change it into, or you represent it as what? As 180 or as 360 plus or minus. And then you check, should you minus something from 180 in order to get 150, or should you minus 360? And then if you can minus something from 180 to get 150, you check, what is it? Oh, here it's going to be 30. So it'll be like, oh, basically 150 degrees is 180 minus 30. Oh, so where I see 150, I will substitute by 180 minus 30. So basically, if I have sine 150 degrees, you change it into the multiples of 90, but only between 180 and 360. So you check. So let me put it like this, guys. We have 180 here, right? And we have 360 here, right? And there's 270 here. So you can tell when a number is less than 270, it's closer to 180. So you use 180. When a number is greater than 270, it means it's closer to 360. Therefore, you use 360. That's how you choose which one between 180 and 360. Now that you know how to choose, you're going to be like, if I have 150, 150 is less than 270, which means it's closer to 180. So I will represent my 150 in terms of 180. How do I do that? I'm going to be like, 180 minus 150 is what? Is 30. So you'll just take 180, you say 180 minus 150 to get your special angle. 180 minus 150 is going to give me what? It's going to give me 30 degrees. That's going to be your special angle, your acute angle. Once you find the acute angle, guys, all the time, once you find your acute angle, you represent that acute angle with 180. You substitute what? 150 with them. So you're going to be like, oh, which means my sine 150 degrees is the same as what? Is the same as sine 180 degrees minus 30. And you punch them on your calculator to check if it's going to be 150 for real. Then you're going to treat your 30 degrees as your acute angle, as your second, as your theta. Does that make sense? So let me show you an example quickly, fast and at a very high speed. All right, let me erase here. Yep. So let's see now. If I have sine 150 degrees and I want to change it or I want to simplify it, I'm going to say sine 180 minus 30. Remember how I found it? I said 180 minus 150 to get the 30. And then I know that I have to subtract the 30 from 180 in order to go back to 150. Then I will treat my 30 as my theta. So I'll just go back to the diagram and say, if I have this, my 180 is positive. So I'll do a positive, right? I'll say, 180. And then my 30, which is my theta, is negative, which means I have to go back, right? I'll be like, in the second quadrant. In second quadrant, remember, it's all students take control. Second quadrant is where my sign is positive. So which means my reduction will be positive. So I'll just go straight to it and write positive sign, right? So I'll say my answer is positive sign. You are left with the special angle. Basically, you are left with the small angle. The one that you treat as theta is the one that you're going to be left with. So you're going to be left with 30 degree here. So you'll be left with sine 30 degrees. And then now, because there's a special angle, sine 30 degree according to our triangle, remember here we have 60, we have 30, and then you'll say square root of 3 here, and then 1 and 2. So sine 30 will be opposite over hypotenuse. So it will be 1 over 2. And then that's going to be your answer. That's how you deal with these ones. Okay, you will see when we do the question that we are here to solve, right? Right now, I'm just introducing everything in reduction formula, guys. So now that you understand this part, there's something, though, that you have to know again, right, with corratios. When you have sine 50 degrees over cos 40 degrees, this is going to be 1. They will cancel each other. Question is why, Mr. Sir? Look, every time when sine carries a 50 or a number and cos carries another number, of which the two numbers, when you add them, they give you 90 degrees, they will be equal all the time. So every time when you realize that you don't have a special angle, let's say you have 35 and 65, for an example, or you have 50 and 40, or you have 70 and 20, those numbers that add up to 90, but the other one is carried by sine and another one is carried by cos. sine is on top or at the bottom, where cos is on top or at the bottom as well, like on either side of the division line, just know they're going to cancel each other. You can punch it on your calculator and say sine 50 over cos 40. You'll realize that you're going to get 1. So most of the time when you realize that on your simplify, on your question, you see your reduction formula leading to numbers that are not, they are not special angles, just punch them on your calculator on the side and check. They're going to be 1. So just know, oh, sine is carrying a number, cos is carrying another number. Those numbers, when I add them and they give me 90 degrees, they cancel each other. They are equal because they are co-ratios. Clear? I'm not going to dwell too much into that, but just know that. So in your exam, you're going to see something like that. Just cancel that. They're going to give you 1. Now we are moving to the fourth one, right? With the fourth one, every time when you see a trig ratio carrying a squared, for an example, if they say sine squared 180 degree plus theta, as long as there's a square, there's no need to do the mnemonics. That's the beauty of a square. Every time when you see a square, an exponent of 2, just know that you don't need to check on which quadrant it's going to fall into. Just go straight to saying, as long as it's 180 or 360, just go straight to saying sine squared theta. And if it was maybe sine squared 90 degrees minus theta, as long as it's a square, but you check, 90 always leads to cos. So it's going to be cos squared theta, because a square will always yield a positive. So there's no need to know whether it's going to be positive or negative, right? So every time when you see a square, the answer will always be positive. If it has a 90 and a 270 with a square, the answer will change from sine to cos or cos to sine, and they're all going to be positive, and the square will still be there. But if it's a 180 and a 360 with the square, the sine will remain the sine, the cos will remain the cos, the square will still remain there. You just remove the 180, you just remove the 90 on the other one, you are left with the theta, always. So when there's a square, you don't need to check, you just go like, my answer is positive anyway, because there's a square. So that's the third one. When there's a square, right, your answer will always be positive. So that's the part a lot of people are like, I see a square. Nah, don't worry about that, right? Last but not least, which is another challenging concept for a lot of people. When there is, when the big ooh is greater than 360, when we have a bigger ooh that is greater than 360 degree, let's say they gave you something like sine 540 degrees minus theta, right? When you see 540, you realize, this is greater than 360. So you don't need to stress. Just subtract 360 from 540 on the side and be like, 540 degrees minus 360, say it's equals to, my answer will be what? 180 degrees. Then you substitute 540 with 180. So you'll be like, my next step, all right, 180 degrees minus theta. It doesn't affect them. When you subtract 360 from an angle that is greater than 360 on your reduction, it does not affect anything. So just subtract 360. So sometimes when you subtract the first 360, you realize that the answer is still greater than 360. Don't worry again. Subtract 360 again. Does that make sense? You don't need to stress. Subtract 360 until you get a number that is exactly 360 or less all the time. And then obviously when you get to 180 minus, you continue with your ooh. 180. Ooh, right? And then ooh, go back with a negative, right? And then it's going to be on the second quadrant, sine is positive. So you'll be left with positive sine theta. So every time when your bigger ooh is greater than 360, subtract 360 until it goes to 360 or below 360. All the time. Clear, guys? This is all about the mnemonics, guys. So now that you understand the mnemonic, let's apply it on the question. So let's go back. Let's go out of the concept. And let's go back. And just like that, we are back, right? So guys, now let's answer this using the mnemonic, okay? That's why on the side I drew the Cartesian plane so that we can do our right? And then which means here, remember, it's all students take control. We know that all of them are positive in here. Sin theta is positive in here. Tan is positive. Cos is positive. When sin is positive, it means others are negative. When tan is positive, others are negative. When cos is positive, just like that, right? So now let's answer this question. You'll realize that in my question, you realize that we have a square there, we have 90, we have other angles that are greater than 360, we have where we don't have variables. So basically we're going to apply almost everything that I taught in the concept on one question, so that you can see that you can do a reduction formula that is mixed up like this. Okay, so guys, let's answer this one. So the first one, you can see, right? Guys, this is easy, right? You can see that they started with the negative theta and they said minus 180. What did I tell you? You will always start with the bigger O, right? You rotate and then you can go back to the smaller O all the time. So on the side, I'm going to be like, remember, you'll do something like this. You'll be like negative 180. It's going to be O, right? And then negative theta, you continue, but you drop into the second quadrant, which is O. You drop in here. In here, sine is positive, right? So you're going to say cos is negative, right? Because we're looking at a cos. So I'm going to be like negative cos theta, just like that. Then again, you check now, tan, again, negative 360. Remember, we start with the big O before we go to the small O. So negative 360 is O, right? And then positive theta, we go back in the positive direction, which is O, first quadrant. In the first quadrant, all of them are positive, right? So which means I will be left with tan theta. Makes sense. Then I go to sin negative theta. Remember, there is no 360, 180, 90, blah, blah. It is just theta. So we always start here, right? When you start here, we are looking at the sign next to theta, which is negative. So the negative direction is this one. And I'm going to drop into the first quadrant that I go to. So it's just going to be O because I'm moving theta. So it's just going to be O. There's no O because there's no multiple of 90, right? So it's just going to be O. And in here, all students take control. Cos is positive, which means sine is negative. Guys, this is easy, right? So I'm going to say what? I'm going to say here I will be left with negative sine theta because sine is negative in the fourth quadrant. Then now I have sine 270 plus theta. Let's see. Positive 270, right? Ooh, 270 is here, right? And then plus theta, fourth quadrant. Ooh, in here, sine is negative. So I will write my negative sign, right? So I'll say negative, not sine though. And then I remember 270 and 90 give me a co-ratio of sine and cos. In the question, I have sine, which means my answer will take cos theta. Clear? And then you go to the denominator, right? You're going to be like, now we have sine squared. Remember, guys, every time when you have a squared, I told you there's no need to do the ooh because the answer will just be positive. And now you check, it's 180, which means my sign won't change. So if my sign won't change, I will just have sine squared theta. You go straight to it because there's a squared, right? And the next one again, now we have cos theta minus 90. Then remember, 90 is there, so I'm going to be like ooh again. Negative, we start with the negative 90, right? So negative 90, we stop here. It's a negative direction, right? And then positive theta, our theta is positive here. So I'm going to be like positive, I go back. Ooh, I go back to the fourth quadrant, so I drop, right? So in my fourth quadrant, cos is positive, which means my answer will be positive, right? Now that I know my cos will be, my answer will be positive, I check again. I have 90. 90 means I will change my cos to sine. So I will write sine theta. Clear, guys? Then you go to the next one, tan, right? But you see there's no variable, which means I have to change 135. So my 135 will be what? It's a negative 135 degrees. So you put the negative outside, you deal with 135 inside, okay? Then you're going to be like what? Negative, open bracket. 135 is closer to 180 than 360, remember? So I have to represent 135 in terms of 180. So I'm going to say, what can I subtract 180 by in order to go back to 135? By 45. So I will say minus 45 degrees. When you punch in this on your calculator, you'll go back to this, right? So which means where I see 135, I'll substitute by 180 minus 45. The negative for 135 is outside the bracket. Now it's going to multiply both the terms inside, right? So negative 180 times, negative times 180 is negative 180. Negative times negative is going to give me positive 45. When you punch this in your calculator, you're going to get this. That makes sense. So which means where I see negative 135, I'm going to substitute by 180 plus 45. So that's what I'm going to write. I'm going to write tan. Let me write it in red so that we can go back to it, right? So I'll say tan what? Negative 180 degrees plus 45 degrees, right? Then we go to cos 960. Again, this does not have a what do you call a variable, right? If it doesn't have a variable, it's nice, right? But again, it's greater than 360. I told you, every time when you have an angle that is greater than 360, just subtract 360 until you get to a number closer to 360. Does that make sense? So I'm going to be like 960 minus 360. It's going to be 600, right? So I'll be like 960 on the side minus 360. The answer will be 600. 600 is still way bigger than 360, right? So I'll be like, again, 600 minus 360 equals to what, right? It's going to give me 240. So I see is 240. Now that my angle is smaller than 360, I realize that this will almost look like this one here. So I have to change it in terms of 180 plus or minus, because 240 is less than 270. You can rewind your video and go back to the concept where I spoke about this, right? So 240 is closer to 180 than it is closer to 360, which means I will represent 240 in terms of 180. So I'll be like, oh, now 240 is basically the same as what? As 180, not minus something, because 240 is bigger than 180. I have to add onto 180 to get to 240. What should I add 180 with? In order to get 240, I have to add it with 60. So 180 plus 60 will give me what? 240. So which means where I see 240, I'll substitute by 180 plus 60. Doesn't make sense. So which means now I can write this one with green. I'll be like cos 180 degrees plus 60 degrees. Clear? So I'm still going to do the oo for that, right? Then the next step now. Remember, I had my negative cos theta times, and I told you after you do the ooh for tan, the next step is to change your tan into what? To sine over cos, right? So I'm going to change it now. Why not? Sine theta over cos theta. Then multiplied by negative sine theta, multiplied by negative cos theta, all over, right? Sine squared theta times sine theta. Now I'm changing these ones now. Remember now, I have negative 180 plus 45 is more like theta. So I'll use the ooh, right? So I'll be like, on my side, I have the ooh here. I can be like negative 180, ooh. Positive 45 is going to be, it falls in here. All students take. Tan is positive here, which means my answer will be positive tan 45. So I'll just be like positive tan 45. I will write it here. I'll say tan 45 degrees. So remember, I treat my 45 degrees as theta, right? Then I go again to cos. Cos again, right? I'll be like positive 180, right? Positive direction. And then positive 60, I still continue in the positive direction, but I drop because 60 is an acute angle. It's my small So it was right? So in the third quadrant, my tan is the one that is positive, which means my cos is negative. So my answer will be negative cos 60 degrees. So that's what I'm going to write. I'm going to say times negative cos 60 degrees. Guys, this is easy, right? Now I can simplify what I have at the top there. I can see that my cos theta will cancel this cos theta, right? And then I'll be left with what at the top? I'll be left with negative cos theta times sine theta times negative sine theta all over sine squared theta times sine theta times. Now, tan 45 degrees is what? According to our special angles, see here, according to our special angles, when you have 45, here you'll have what? You'll have square root of 2, and 2. So tan 45 will be what? Opposite over adjacent, which is basically square root of 2 over square root of 2, which is 1. right? So I'm going to write exactly that. I'm going to say tan 45 degrees is exactly 1. So I say it's 1, right? And then I have negative into. Now, cos 60 degree, again, you go here, we check, it's a special angle. 60 degree, when you have something of this kind, you have a 60 here, and you have 30 here, square root of 3, right? 1 and 2. Cos is adjacent. Remember the SOHCAHTOA, right? Cos is adjacent over hypotenuse. 60 is here. So I'm going to say adjacent over hypotenuse. So it's going to be 1 over 2. So cos 60 degrees is basically 1 over 2. So I'm going to write it. I'm going to say 1 over 2 here. The negative is outside. Makes sense? Then I'm done with those special angles, guys. Now I'm going to cancel on my numerator and denominator stuff that are the same. So I can see that my sine will cancel my sine. And on this sine squared here, I have sine theta times sine theta, right? So 1 sine theta will cancel 1 sine theta. I'll be left with 1 sine theta at the bottom, right? So which means, and then now I will check my negatives. I'll be like negative times negative, positive. Positive over this one, negative, negative. So my final answer will just be negative because I have odd number of negatives. If I had even number of negatives, my final answer will be positive. Do that make sense? Then I check, okay, now that my final answer will just be negative, I'm dealing with what I'm left with. I'm left with cos at the top. So I'll be like cos at the top all over, right? At the bottom, I'm left with only sine and the half. So sine theta multiplied by the half. And if I want to simplify, I'll just say, therefore, I'm left with 2 cos theta over sine theta. And then you are done. How did I get that? Remember, this is basically cos theta over sine theta divided by 1 over 2 because this is part of it, right? And then if I don't want to say divided by 1 over 2, I can say what? Fractions, right? Multiplied by 2 over 1, right? 2 over 1, right? And then the 2 will go here. Do that make sense? That's how it works, guys. So basically we are done, and that is just about it. Guys, you can watch this video maybe twice. Or you can watch like the first half where I was explaining the concept, watch it, finish it, and then go back and watch it. Then now watch the second part, the second half of the video where I'm answering this question. Watch it as you just listen to what I'm saying, and then repeat it as you are writing down as well to see if you can do what I'm doing. And then you'll see you have mastered the reduction formula. If you go to any question on your past paper, even in your textbooks, you realize that there is no question that is more challenging than the one I've treated. And all of them can be done by applying everything I've taught in here. So come on, guys. Continue telling me that math is easy. You'll see. You'll see. I don't know, man. I'll come up with more simple ways because it's me. It's MrSir. I'll always come up with tricks. Anyway, let's just go in here. You know how we do it. We go in here. And what are we going to do when you are in here? You guys are going to subscribe. Come on. You're going to go subscribe. And you're going to share because you're a nice person, right? So that others can pass as well. And you're going to like the video because I know you liked it. Come on. Right? And then you're going to comment with other concepts that you'd like me to break down and end. Guys, I'm out.